This is the continuation of topic 12-1, solving systems by graphing. So now we come to a problem of how can you tell whether an ordered pair is a solution to the system of your equations. So we're basically given two equations or more, but in this case we're going to have two, and we're given a possible solution. If it is a system, that means that solution must be where those two lines intersect, which means that point has to be in both graphs. So the way that we're going to do this is we're going to plug it in. We're going to use the point and plug it in. So our point that's given on our first set is 2, 1. This tells us that x is equal to 2 and y is equal to 1. So we start with our first equation. 3x plus 2y equals negative 4. We're going to plug in x for 2 and y for 1 and see if we do come out with the true statement. So we get negative 3 times 2 plus 2 times 1. And the question is, does that come out to be negative 4? So the left-hand side, I'm going to put into my calculator and see what comes up. So with my calculator, I'll type in exactly how it looks. Negative 3, open parenthesis, 2, close the parenthesis, plus 2, open the parenthesis, 1, close the parenthesis, press enter. And we get that it is equal to negative 4. So negative 4 does equal to negative 4. This is a true statement. So we definitely know that 2, 1 is on the point, or is on the graph of our first equation. Now we have to check the second equation. X plus y equals 3. Again, for x, we're going to plug in a 2. So we have 2 plus 1 equals 3. And the question is that a true statement? You can use your calculator or do it on your own. 2 plus 1 does come out to be 3. So we get 3 is equal to 3. This is also a true statement. So that means this point is also on our second graph. Therefore, that tells us then the point 2, 1 is a solution to this system because it is a point on both graphs. That means this is the point where those two lines will intersect. So now we're going to check the second one. Our second problem, we have our point is a negative 3, negative 10. Again, this tells us x is equal to negative 3, y is equal to negative 10. So we're going to plug it into our first equation of x minus y equals 7. If x is negative 3 minus y is negative 10 equals 7, the question is, are they equal? Again, I'm going to pull up my calculator and type in the left-hand side. Oops, so sorry. So we'll type in negative 3. It's negative because that's the first thing. Then minus. In parentheses, we'll put in negative 10. Close it off and press enter. That comes out to be a positive 7. So 7 does equal 7. Yes, this is a true statement. So let's check the other equation. 3x minus y, does that come out to be a negative 19? So we'll start with 3 times a negative 3 minus a negative 10 for our y. And the question is, does that come out to be negative 19? Let's put the left-hand side into our calculator. Move the calculator over. That'll give us 3, open parenthesis, negative 3, close it, minus, open parenthesis, and negative 10, and close the parenthesis. And I left off a parenthesis. I left off a couple parentheses. There we go. The calculator is only as good as the user. And that comes out to be 1. So we get 1, and that does not equal a negative 19. So that tells us that the point negative 3, negative 10 is not on the line of 3x minus y equals negative 19. So since it is on the first one but not on the second one, then it is not a solution. because to be a solution, it must be a part of both lines. So to summarize what we've done here, if you're given a solution, then the way that we figure this out is we're going to plug the point into both equations. Looks like I'm doing EG. Let's try that again. Both equations. And both must be true to be a solution. So if you plug it in the first equation, you get a no. You can stop right there because it's not a solution to the first equation, so there's no reason to do the second one. Our last problem is kind of putting it all together. The following graph shows a solution to a system of equations. Which system of equations is best represented by the graph above? So I see that there's a solution, but I can't really take that point and plug it in. So what I have to do is try and see what two equations will actually graph these two things. So let's start with the equation that has a positive slope. Notice one of these equations has a positive slope and the other has a negative. So we're going to do the positive slope equation first. Looking at the positive slope equation, we see that its y-intercept is at -3. So I'm looking for an equation that has a y-intercept at -3. And then the slope, if I can find 2 points, it looks like it's going up 3 and then to the right 3. So a slope of 3/3, which equals 1. So I'm going to look for a positive slope with a y-intercept at -3. So A cannot be it. I'm looking at the positive slope with a y-intercept of -3. That's a possibility for C. B have a positive slope of 1 and a y-intercept of -3, so B is a possibility. And then D, even though it has a positive slope, the slope is 2, so we know that that one's out when we have our y-intercept of -3. So it matched one part, but not both. So now let's look at our one that has a negative slope. Our negative slope, it appears is that the y-intercept is at a positive 10. So let's look at the two that we are dealing with. On B, the second equation doesn't have a y-intercept at positive 10, but C does, so B is out and our answer is C. So it's just using some deductive reasoning in order to come up with your possible answer. This will conclude, finally, topic 12-1.